Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2019. The question was from the concept of work per energy and was a numeric type question. The question was fairly simple and I'm sure most of the students in India would have gotten free marks in this. I'm going to tell you a very good way and very short, crisp and amazing way to solve this particular question. Let us see what is being asked in this. A particle is taken over a closed curve A, B, C, D, E, F, A, and in the presence of a force which is defined by this function. The value of alpha is a negative constant, and we have to find the value of the work done by this force over this closed loop. Now, one way of doing this question is to, straight away just do f dot ds over the different paths, like from OA and then AB and then BC and that ways, and then add all the work done, and you're going to find the answer. But if you look at this force function carefully, then you will be thrilled because this function can be written like this, correct? I have written 2 alpha x as alpha x plus alpha x. Now, this part of the force is conservative. I am sure most of you will recognize this, that if you look at this part of the function, then this will be conservative. This is conservative in nature. You can see that if this was the only function given to us, then del fx, this will be the x component, del fx upon del y equals to del fy upon del x, right? So this both becomes 0, and hence we can say that this part of the force is conservative. There are other ways also to see if the force is conservative, but I'm sure that all of you will recognize that this part of the force is conservative in nature. Hence we can say that this part of the force is not going to do any work on this closed loop. So we can say that effectively the work will be done by this part of the force only. Hence we can again redefine f dash as alpha x j cap. Now you can see this question will be finished in 30 seconds. The force has only j component, and if you put the value of alpha as negative, so this becomes minus x j cap. So force is only j component. So on this part, x is 0, so there will not be any work done. On this part, the displacement is in positive x-axis, so force is perpendicular to displacement, and hence there will be no work done. On this part, x has a fixed value of 1, so force becomes minus j cap, and displacement is also happening in the negative direction and is of the value 0.5. So we can say that work done over the path BC will be simply force ka magnitude is 1, displacement ka magnitude is 0.5, and both force and displacement are pointing in the downward direction. So that will be cos 0, which will give us this. On this path, again force will not do any work because force is perpendicular to displacement. On this path, again BC, this will become DE will become, force has a magnitude of 0.5 because x has a value of 0.5 on this path. Displacement is 0.5 and both force and displacement are pointing in the downward direction. So we'll write force, which is 0.5, displacement, which is 0.5, and cos 0 is 1. So this will become 0.25. And on this, again, force is 0. Sorry, work done is 0. So we can say that total work done will be 0.75 joules. I hope you would have appreciated this method and you would have enjoyed the solution. Thank you.